All right, so series example 2. All right, so first I've drawn the finite sum. The area represented the sum from 1 to 4, 1 over n. Notice the scale is off, right? Here I've got the scale is off here. This is 1 in the AN or Y direction. Okay. But I want to be able to fit in a bunch of rectangles. Okay. So as opposed to the previous video where I drew these to the left using the left endpoints now, or the right endpoints, now I'm using left endpoints. Okay, but in any case, you can see that this represents this finite sum. Let's see, this rectangle here has a width of 1 and a height of 1, so this is 1. 1 times a half, that's your half, plus 1 times a third, that's a third, plus 1 times a fourth, that's a fourth. Okay, now remember what happens when we extend this. We put an infinity here, and this thing just keeps on going. Dot, 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 on to infinity. Continuation to infinity. Okay, so 1/4, let's see. And now let's say a 1/6, somewhere in there. And then a 7th. And then an 8th. And a 9th. Okay, and this thing continues on like this. Okay. And these are each of these points here. So on like that. Okay. Now the thing to notice is that think of the function f of x equals 1 over x. Now remember, this graph looks like something like that. Graph of that thing. All right. So that graph goes right through each of these points. Remember, an is the discrete analog of a continuous function, f of x. So So in blue, I've drawn f of x equals 1 over x. And now let's think about the improper integral from 1 to infinity of 1 over x. So 1 x dx. Now I'll show this in just a minute. You'll see that this actually diverges to infinity. Now notice that this area that this represents, let me do that in blue, is underneath the area represented by the rectangles for the infinite sum. So it makes sense to think if this doesn't go to anything, because this is always above that, right? Because this is always above that, and that doesn't go anywhere or go to narrow in on any number, it makes sense that this can't narrow in on any number. Okay, and so that's the connection that is given, the critical fact on page 2 excuse me, of the Notes and Learning Goals for the series assignment. This is the intuition. So the idea here is that whatever happens to this is the same as whatever happens to this. So if this diverges, this diverges. If this converges, then this converges. Okay, so what we're going to do is we're going to look at convergence or divergence of this. And we'll see that it diverges. Since this diverges, we know that diverges. And that all has to do with the area. I'll save that for the next video.